We see images of the brain everywhere these days, but usually they are static and immobile. But in fact, the brain is never still. Functional MRI is here animated to show that even a resting brain is seething with activity. We analyze that activity with a technique called independent component analysis, which picks out distinct brain networks called components. Here we see the interaction of 15 independent components, each a distinct brain network. This is the brain of one individual, simply resting in the scanner with her eyes open. The video plays in real time, inviting us to think along with the scannee, following the waves of activity sweeping among the folds of her cortex. Animation immediately conveys the main insight of network dynamism. It shows us that at every moment there's a different global configuration of brain activity. Instead of a snapshot, a visible story unfolds. But what is that story? Our gaze darts among the glowing blobs. Even 15 components can combine in myriad different sequences, too many to keep track of. Some in view, others not. The story is too dense visually to be read. So let's simplify. Let's take just the single point of greatest activity as a stand-in for the component blob as a whole. That is, we replace the expansive blobs with uniform symbolic nodes. When activity is greatest, the node markers swell. When two nodes are active at the same time, the link between them fattens. Where there is no activity, the nodes and links disappear. Thus, the brain crossfades from detailed cortex to an abstracted network of 15 points of light, while still tracking the varying activity among them. This adds a kind of clarity, but is still bewildering. Too many nodes to interpret in real time. Visualization has its limits, so let's try sonification. Take each of these nodes as a note and listen.